All right, let's dive in. Today, we're talking about a science that is, and I mean this quite literally, at the center of absolutely everything. We're talking about chemistry, and I promise by the end of this, you'll get exactly why it has such an incredible reputation. So, you've probably heard this phrase thrown around before, right? That chemistry is the central science. It's a really bold claim when you think about it. It suggests chemistry is the bridge that connects the most fundamental laws of the universe with the unbelievably complex world of living things. Is it just a catchy slogan for textbooks, or is chemistry truly the linchpin holding the entire world of science together? Well, that's the exact question we're going to answer today. And to do that, we need to start right at the beginning. To really find our answer, we have to go all the way back to basics and ask a super simple question. What are things, actually made of? At its absolute heart, chemistry is the study of stuff. Yep, just stuff. It looks at matter, which is just a fancy word for anything that has mass and takes up space, and it asks three key questions. What is it made of? How can it change? And what happens when you mix it with other stuff? That's it. It's the science of what things are, how they work, and what they can become. And look, this isn't just happening in some far-off laboratory. It's happening all around you right now. When you cook breakfast, the proteins in the egg are chemically changing their shape. When you use soap, that's just molecular attraction grabbing onto dirt. Even your own body, right now, digesting your last meal, that's just a giant symphony of chemical reactions. You are, for all intents and purposes, a walking, talking chemistry experiment. Now, because all the stuff in the universe is a pretty big topic, chemists have to break it down. A great way to think about it is like they have 5 different lenses, and each one is designed to focus on a specific part of the world of matter. So here are the big 5: organic, inorganic, physical, analytical, and biochemistry. Each one is a different slice of the same pie, giving scientists totally different ways to understand all that stuff we were talking about. Let's start with the classic duo, organic and inorganic. The huge difference here really comes down to one little element, carbon. Organic chemistry is the study of things with carbon in them. That's the building blocks of life itself, but also things we use every day, like plastics and fuels. Inorganic chemistry, that covers pretty much everything else, from the metals in your phone to the salt you put on your food. Then you've got physical and analytical chemistry. You can think of this as the how versus the what. Physical chemistry is all about the how and why. It uses physics to understand the energy and motion behind chemical reactions. Analytical chemistry, on the other hand, is the detective. It's all about the what. It asks, what's in this sample, and exactly how much of each ingredient is there? This is the branch that tells you if your water is safe or how pure a new drug is. Okay, so we've got our different lenses. Now we can finally put them all together and prove that central science claim. Let's see how chemistry really is the great science connector. And this table just lays it out perfectly. Look, physics gives us the fundamental rules of the universe, right? Well, chemistry is what applies those rules to atoms and molecules. It's how we can design new materials for solar panels. And biology is the study of life, but life itself is just driven by an insane number of chemical reactions. Think about your DNA. It's held together by precise chemical bonds. And then you have the earth sciences. Geochemistry tells us what rocks on Mars are made of, and environmental chemistry helps us track pollution. So chemistry basically translates the laws of physics into the reality of the world we see around us. That claim, it's totally true. It really is the central science. But this whole connection isn't just some academic idea. It has a huge impact on our daily lives, on our technology, and on careers, taking chemistry right out of the lab and into your world. A degree in chemistry doesn't just mean you're going to be wearing a lab coat. Though, hey, you might. It opens doors to an incredible range of jobs. You could be a forensic scientist solving crimes, a food scientist creating brand new flavors, or, and this is one a lot of people don't think about, a patent agent using your chemistry know-how to protect the next big invention. These skills are in demand everywhere. And that value is real. You can actually see it. This number, £190,000, is the average lifetime earnings boost for chemistry graduates in the UK compared to someone who doesn't have a degree. That's a powerful statement about how valuable these skills really are. But it's about so much more than just the technical knowledge. As Dr. LaRosa points out here, studying chemistry gives you a powerful problem-solving mindset. It literally teaches you to analyze really complex systems, to think logically, and to build solutions from the ground up. And that way of thinking, it's priceless in any industry. So you see, chemistry isn't just another subject in a textbook. It's a fundamental way of understanding the world and a powerful tool for changing it. Whether it's developing new medicines, creating sustainable materials, or tackling environmental disasters, the core ideas of chemistry are right there. So the only question left is, what problem will you solve?